Bismillahirrahmanirrahim. Welcome to lecture number 4 of the course Object Oriented Programming. In the previous lecture we have seen what is a constructor. I have shown you the example program and placing class in a separate file and the main function in a separate file, and then creating the object of that class in the main function, a destructor. And we have seen the example program that when the destructor is called, so the constructor is called whenever the object of that class is created, the constructor is called implicitly, and the destructor when the object of that class is destroyed, the destructor is called implicitly. Means that automatically they are called. The user do not need to call them explicitly, like the user need to call the other member function of the class using that object. So दूसरे functions को जिस तरह से call किया जाता है, that is implicit call, means that user उनको खुद से call कर रहा है, but implicit means they are automatically called. So constructor जब भी object create होगा, the constructor will be called, and जब भी object destroy होगा, then the destructor will be called. Now object creation का तो पता है, अब destroy object का मतलब ये है, for example, you create a function, you write a function, and then you call that function from the main function, and within that function, this is just the ordinary function, not the member function of the class. Let's say the name of the function is xyz, the ordinary function, and you have a class, let's say time, and from the main function you call the xyz function, and within xyz function you create an object of time class, right? So when you create an object, the constructor will be called. So when the function xyz finished its execution and the control will be transferred back to the place in the main where you call the time function, the object that is created within the xyz function will be destroyed then, right? And at that stage the destructor with that object is called. And then we have seen constructor with argument, and I've shown you the example program, and today we will see what is the overloaded function, how we can write an overloaded function. We will see how we can write an overloaded constructor for a class. We have already seen the same thing in the previous lecture, but today we will explain it. I will explain it a little bit more detail of that overloaded constructor. And then we will see the constant objects, constant member function of a class, and constant data member of a class, and constant object as function argument. That how you can pass the constant object to a function, right? So you can have a constant object, you can have a constant member function within the class, you can have a constant data member as a private data member of a class, and then you can have a constant object as a function argument. We will see each of these in detail with examples. Then we will see what is a friend function, and the very important concept, this pointer. So object as function argument. So this is the class that we have seen in our last lecture. This is a distance class. It has two private data member, feet and inches, and this is the distance constructor. This is the default constructor with no argument, and this is the constructor with two arguments. And the add distance function that we define, we write the prototype of add distance function within the class definition, but we provide the definition of add dist function outside the class definition. And this is our main function. So we already know these things. So overloaded constructor. Before going into the detail of overloading constructor, because the constructor is a function, right? So let me show you an example of overloaded function, how we can overload an ordinary function, a simple function, right? And then we will it will be easy for us to grab the idea of overloaded constructor, although there is a constructor in this example that is overloaded. But let me first show you how we can how we can write how we can make a simple function overloaded, right? Let's go to the defc editor. Okay, so let me write a very simple program. So now I'm writing a function add that is used to add two integer, and another function with the same name add that can add, let's say, 3 integers, right? So now here in this example, add is the overloaded function, right? Now I can simply call this function here. Let's say 3 plus 4 plus 5 equals 2. Now call the function add with passing 3 arguments. Now you can realize that when I call the function add with the 3 argument, then which function will be called? The function with 3 arguments. And when I call the function with 2 arguments, the 2 arguments add function will be called, will be executed. So let's say this is 6 plus 7. Now let me write the definition of these function. Int add int z, and within this definition I just have a one statement, that is return x plus y plus z, right? And same is the definition of add function having 2 arguments. So this is an example of overloaded function, right? We overload the add function. So what are the rules? The rules are that whenever you make the function overloaded, you have to tell the compiler how it can differentiate between these 2 function calls, because the function name is the same, right? So add function, we have the add function for 3 integers, we have the add function for 2 integers, 2 arguments, right? So you have to tell some mechanism to the compiler to make it different, to make it differentiate between these 2 function calls. And what is that mechanism? Either the number of parameters passed to that function must be different, and the second thing is that if the parameters are the same, then the type of the parameter should be different, right? So here in this example, the number of parameters passed to the first function is 2, and the number of parameters passed to the second function are 3. So now when we call the function with 3 parameters, the compiler knows that we are going to call add function with 3 parameters, right? So now you can compile and run this program. Before that, we have to save it. Okay, now this is the answer, right? So if the number of parameters are same, then we have to make it like the type of the parameters should be different. For example, float comma float 6.5, sorry, 6.5, 7.5, this is 6.5 and 7.5. Now let's compile it. Okay, there's no function with 3 parameters, so we have to write it like this. Okay, we have to change it as well. Now the return type of this function should not be add, it is float, but the first add function we have to pass 2 parameters, and the second add function also takes two parameters, but the type of the parameters are different. So we have to provide some kind of mechanism. Either the number of parameters should be different, and if the number of parameters are same, then the type of these parameters should be different, right? So let's make it float. Right? So okay, we can write double. So double is also the float type, or we can make it like this, that we can declare float type variable x is equal to 5.5 and y is equal to, let's say, 6.5. We can pass these parameters here, x comma y. Okay, there's no variable z over here. Now we are passing two float variables to the add function, and here are the results. 6.5 plus 7.5, that shouldn't be 12. Okay, so for the overloaded function, you have to either the number of parameters should be different, or if the number of parameters are same, then the type of these parameter should be different. So it's 5.5 actually plus 6.5, that's why it's 12. So here it is 5.5 plus 6.5, and that is 12, obviously, right? Now let's come to the point. So here the constructor is overloaded. You can see we have the two functions with the same name distance. So the rules are either the number of parameters should be different, or if the number of parameters are same, then the type of these parameters should be different. So you can see the number of parameters different. Here we have no parameters, but here we are passing two parameters, right? So now when we create an object like this, dest1 and dest3, then this means that we are calling the constructor, or the compiler will call the constructor implicitly. Which constructor? The constructor with no argument, because we are not passing any value over here. We are not passing any value with the creation of objects, right? But with dest2 objects, we are passing two values, 11 and 6.5. Now which constructor will be called? Not the default constructor. Here with when the dest2 object is created, the constructor with two arguments will be called, that is feet and inches, right? So dest2 जब object create होगा, the constructor distance call होगा, but that constructor should be two argument constructor, right? So it is convenient to be able to give parameters, to give variable of type distance a value when they are first created. Instead of initializing it with 0, you can assign some kind of values to to the private data member of the distance object, and you can do so by writing the overloaded constructor. So this is when this function call is executed, which defines an object and initialize it to the value 11 for feet and 6.25 for inches. So distance dest1, dest2. So when this is executed, then no argument constructor is called or invoked, and that is called the default constructor. So since there are now two constructors with the same name distance, we can say the constructor is overloaded. Like we have the add function that is overloaded, and we have at the first place we create the add function with one add function with 3 parameters, the other add function with 2 parameters. So function name is same, but the number of parameters are different. So this provides the compiler a way to make differentiate which function is called, and if the number of parameters are same, and then the type of these parameters should be different, right? Now member function defined outside the class. We have also seen this thing that we can define the member function outside the class, but we have to write the function prototype inside the definition of the class. So such function needs to have the prototype declaration within the class, and the function name add dest is preceded by the class name, distance, and a new symbol, the double colon. This symbol is called scope resolution operator. So you have to tell that add distance function belongs to a distance class. Why it is so? Because you can have the classes, for example, you can have a class distance in which you calculate the store the distance in feet and inches. You can have a class distance 1, for example, and where you can store the distance in kilometers. You can have a class distance 2, where you can store the distance in miles, for example, and each of these classes has add distance function. Then if you are going to write the definition, for example, outside of these class, then you have to tell that that particular add distance function belongs to which class. Either it belongs to distance class, or distance 1 class, or distance 2 class. So you have to tell this with the class name and the scope resolution operator, that is double colon sign, right? This is the declaration before the definition. So this thing tells the compiler that this add function belongs to a distance class, right? It is the way of specifying what class something is associated with. In this situation, distance, then scope resolution operator add dest means the add dest member function of the distance class. Now, a structure and classes. Now we know what is a structure, and now we know how we can declare a class and what is a class. So we use structure as a way to group data, and class as a way to group both data and functions. In fact, you can use structure in almost exactly the same way you can use the class. The only formal difference between class and structure or struct is that in a class the member functions are private by default, but in a structure they are public by default. So by default means that if you write some variable inside the definition of the class and the function, if you don't mention public, then they are assumed to be private. There's no need to write a private keyword, right? Because by default they are private. If you have to make it public, you just can write the public keyword. You can use the public keyword. So in classes, by default, if you won't mention any access specifier like public or private, then the member function or the data member are considered to be private. But in structure they are public. So if you have to mention that in class definition the functions should be public, then you have to use the keyword public before these functions. Now let's see the objects, classes, and memory. So you can see that these are the 3 different objects of the same class. Consider these 3 different objects: object 1, object 2, and object 3. So object 1, 2, and 3, and they belongs to the same class. Now when the object is created, the attributes of the object, or we can say the data member, each object has its own data member. That is, so in class definition we have data 1, data 2. So when object 1 is created, data 1 and data 2, these variables are for the object 1. When object 2 is created, data 1 and data 2, these are the variable for object 2. But the functions are shared, right? So we have the same copy of the function. So when object 1 call the function, it called the function, and if function 1 or function 2 uses data 1, then they are the data of the object 1. If function object 2 call any of these functions, function 1 or function 2, then the data 1 and data 2 are of that object, right? Now let's see the constant objects. Some objects need to be modified and some do not. So keyword const is used to specify that an object is not modifiable. Modifiable means that you you can change the value of the private data member of that object, right? So if the object is constant, then it is not possible to change the value or to change the private value of the private data member of that object. And we can use the same keyword that we have used for the simple variable to make it constant, like a keyword is const. So any attempt to modify the object, any attempt to modify the constant object should result in compilation error. So here we have declared the object of time class. So time is the class, noon is the name of the object, and this is a constant object, and these are the parameters with which we have initialized that object. If you remember, if we declare a constant integer variable, we have to assign the value to that constant integer x, let's say, at the time of the declaration, right? So here we are going to create or declare an object noon of the class time, and at the creation time of the object we have to assign it some values, right? And now further onward in the program, it is not possible to change the value of the noon object. So this declares a constant object noon of the class time and initialize it to 12 noon. So 12 hours 0 minute and 0 seconds. Now constant member function. A constant member function will not allow to modify the private data member of the object that call that function, or the handler object. Basically जिस object के साथ आप member function call करते हैं, that is the handler object, and if the function is the constant function, then it is not possible to change the parameter of that function, of that object private or change the value of the private data member of that object, right? Let me say it again. So if the function is constant, then it is not possible to change the value of the private data member of the object who call that function, actually, right? So if I write let's say d1 dot setDest function, if I call this function with the object d1, then in setDest function it is not possible to make changes in the value of d1 object. Now this is an object, let's say this is a class, A class, whose name is A class, the private data member is alpha. Now this is a non-constant member function, non-FUNC, non-constant member function. So if we create an object of A class, right, it is possible to call non-function, right, with that object, and it will change the value of the private data member of that object to 99. But if we call con-FUNC, that is a constant function, we have write the keyword over here, then it is not possible to change the value of the private data member of that object who call con function, con-FUNC, right? So if the member function is constant, the object that is going to call that function, it is not possible within that function to change the value of that object. Example program, let's see the time class. The data members are hour, minute and seconds, and the member functions are set time, set hours, set minute and set seconds. So these are the setter function and these are the getter functions, and for the getter function we make each getter function a constant function, because getter function should not be able to modify the private data member of that object. Although if we won't write const over here with the get hours or get minute, then it is possible for get hour, get minute or get second function to change the value of the private data member of the object that call those functions. When we make them constant, then it is not possible for these functions to change the value of the object that called these function. And then the print time function, that should also be the constant function. So every function that return, every getter function or every printing function should be a constant function, because we should make that these function constant function. Why? Because we won't allow them by any chance to change the value of the private data member of the object, right? And let's see the example program. Let's go to the example program, and okay, this is the time class now. So this is a simple constructor, a constructor with 3 arguments. We have set function and set hour function. We are going to check if the hour value is in between 0 to 24. That is the purpose of setter function. They check the value, if the value is valid or not. So if the hour is greater than 24, then it doesn't make sense, right? If the seconds or minute are greater than 60 or less than 0, then they are not the actual minute, right? So in that case, it assigns 0 to second or minute. Now get hour function. So this function returns the hours of the object that called get hour function, and this function is a constant function. So it is not possible to write something like hours is equal to 20. If we remove this const keyword from here, we can do like this in the get hour function, but if that keyword is here, then it is a compiler error. Now minute is also a constant function, second is also a constant function, and print time is also a constant function, right? So we create an object wake up, that is not a constant object. We create an object noon, that is a constant object, it should be 0 0. Then we print the constant object and we print the non-constant object. Let's say we call the function set hours for both of these objects. Let's see what happens. With this, it works perfectly fine to change the hours of wake up object, because wake up object is non-constant object, but noon is a constant object. It is not possible to execute set hour function with noon object. So let's compile it. Now it gives error over here, right? So if we comment out this thing and then compile it, okay, now it shows us the time. Yeah, that's it. Okay, the first is the noon time, it prints the time for the noon, and then the wake up time, right? Now const object as a member, as a function argument. So we have seen in the previous example, we can declare a constant object. We can have a member function that is a constant. If a member function is constant, it is not possible to change the value of the private data member of that object, which call that function. And if the object is constant, we have to assign some value or initialize that object with some values at the time of the creation of that object. If we won't, then it is not possible to change the value of the constant object further after the creation of that object, right? Now let's see the const object as a function argument. Now this is the same class as we have the distance class. We have seen the distance class, but the only change is this, the prototype of the add distance function. Now add distance, in the add distance function, the return type of the add dist is now a distance object. It returns a distance object, and the parameter we are going to pass that function is a reference of a distance object that is constant, a constant referenced object of distance type. This means that we are passing the reference of the object to this function, and if that reference is not constant, if the constant keyword is not here, then it is possible for the add function to change the value of this referenced object. So reference object जो as a parameter आप pass कर रहे हैं, जिस तरह आप by address pass करते हैं, if you pass the variable by address, it is possible for that function to change the value of that variable, right? And if you pass it by value, then the change made by that function will be local. But if you pass by reference, so reference is like creating a different name for the same memory location, right? So we will see in detail. And we have the const keyword over here. This means that the add distance function is a constant function, right? This means that it is not possible for the add distance to change the value of the object that called the add distance function. Now this is the definition of the add dist function. So const is over here to tell that the add dist is a constant function. This constant here is tell that the parameter passed to the add distance function is a constant function, and that parameter is a referenced object of type distance, right? So now it is not possible to change the value of d2, neither it is possible to change the value of the object that is calling this function, right? So here you can see this shouldn't be here, this line shouldn't be here, right? Because it is not possible to, if we write inches is equal to 0, then these inches are the private data member of the object that is calling add dist function, right? The object like d2 or d dot add dist. So it is not possible for add dist function to change the private data member of the function of the object which is calling add dist function, right? The handler object. So this inches shouldn't be here because it is not possible for add dist function to change the value of the private data member of the object that is actually calling add dist function, right? So this line, we should omit this line. So in this function we create an object of type distance, and then name of the object is temp. We assign some value, inches value in temp and the feet value in temp. We have already seen the logic in detail in the previous example, in the previous lecture. And then at the end we return temp object. So temp is return, type of the object is distance. Let's see the main function. So this is the main function. Now let's execute it one by one. So in the first statement it creates two objects, dest1 and dest3. In the second statement it creates dest2 object, initialize it with value 11 and 6.25, and then we call the get dest function. This is get dest function. So it prompts the user to input the value of the feet and inches. So let's say user enter the value 5 for the feet and 7.0 for the inches. The next function is the add dest function. Now you can see how we are going to call this function. We need an object to call the member function, and that object is dest1, and we need to pass one object as a parameter to that function, that is dest2. Now how we are getting that object in add dest function? We are catching this argument object in a add dest function as a referenced variable, right? So reference is you are going to create a different name for the same memory location that is allocated for dest2, right? So what add dest will do, it will add dest1 and dest2 and then return a distance that will be copied or assigned to dest3, right? So this is the add dest function. Now it has to declare the reference variable. So it creates the different name for the same memory location. The different name is d2 for the same memory location that is allocated for dest2, right? Like this, you can see it is blinking. So dest2 के साथ d2 आ गया. Now with d2 you can access the same memory location that is allocated for the object dest2 of the main function, right? So main function में जो dest2 object है उसकी जो memory allocate हुई थी, you create this function creates, so this add dest function creates another name for this memory location. That name is d2, right? So now if you write d2 dot inches, that is 11. So the next statement is, so now this constant is over here because to restrict the add dest function to change the value of this reference variable, that is dest2, and this constant is over here to restrict the addDest function to change the value of the object that called addDest function. And in this example, in the main function, we can see that dest1 is an object that called addDest function. Now we create a temporary object. So this is a temporary object, temp. Now temp dot inches is equal to inches plus d2 dot inches. So these inches are the inches of the object that called this function, that is dest1. So the inches of dest1 is 7.0 and inches of d2 inches are 6.5. So that is 13.5. That will be assigned to temp inches, right? And then we have a if condition. If temp dot inches is greater than 12, yes it is, then we have to subtract 12 from inches. temp dot inches से 12 subtract कर देंगे और temp dot feet में 1 add कर देंगे. Now we are going to add temp dot feet plus feet. Feet is actually dest1 object, feet of dest1 object. This is 5. So 1 plus 5 plus d2 dot feet. So d2 dot feet is 11. So 1 plus 5 6 and 11 is 17. So 17 will be assigned to temp. And then the temp is returned. You can see the temp is returned. This means that we have a statement now here, and it is like dest1 dest3 is equal to temp. So the value of the private data member of the temp object is assigned to the private data member of dest3 because both are of the same type, right? So ये वैल्यूज असाइन हो जाएंगी इस तरह से, फंक्शन की एग्जीक्यूशन खत्म होगी और ये वैल्यू 17 और 15 असाइन होगी ऐसे, ठीक है? Then you can print those values using a showDest function. You can print those values. So first the showDest function is called with dest1, so 5 feet and 7 inches, and then dest2 11 feet and 6.5 inches, and then dest3 is 17 feet and 1.5 inches, right? Let's go and see the example program. So this is the example program, the function with no argument, the function with 2 arguments, and getDest function, showDest function, and here is the prototype of the addDest function. You can see this prototype addDest function, that is a constant variable, constant object as a function argument, and this is a constant. This constant is for the constant function, right? Now in the main, we already dry run this thing in detail. Let's now compile it and execute it. Enter feet is 12. So dest1 is 12 feet 1 inches, dest2 is 11 feet and 6.5 inches that we write in the program source code, and then dest3 is 23 feet and 7.25 inches. Now initializing a constant data member. Now we have seen what is a constant object, what is a constant member function, how a constant object is called, is passed as an argument to a function, and now initializing a constant data member. The constant data member means that the private data member of the class that are constant, that start with the keyword constant. So constant data member must be initialized using a member initializer list provided by the constructor, right? So they must be initialized there, otherwise they won't be able to, or we won't be able to initialize constant variable further in the program, or constants further in the program. So let's assume an example. We have a private data member count, and count, and then increment count, that is also a constant. Now constant data member must be initialized as soon as the object is created. So जैसे ही object बन गया है, now you have to initialize the constant data member, because it's the same case when the object is constant, and whenever you are going to create the constant object, you have to initialize with some value. Then afterward in the program, these values won't able to change. So when there is a constant as a private data member of the class, then whenever the object is created, it must be initialized with some value, and then after initializing it is not possible to change the value of the constant. Let's see the example program. So this is the example program in which we have 2 private data member, count and increment. So this increment is a constant, and count as a simple int type. So increment constructor, this is a constructor, add increment, this is a function to add the increment. So increment is, why increment? We make the increment constant because increment is something that is we can say the step, how much step it should perform after each increment, right? So in add increment, we increment the count value by increment, and then in print, now here the print is also the constant function. You can see count cout equals to count. Now this is also the constant function because it won't be able, or we won't want to allow that function to change the private data member of the class. Let's go to the program and see its execution. Now here you can see that first we are going to create a value object whose value is 10 and increment is of 5, right? So before incrementing, we print that value like value.print, so it is printed on the screen because in the print function this is the output statement. Then in for loop, for I int j is equal to 0, j less than 3, j plus plus, we try to increment the value, and then after increment we print the value and then value dot print, that is printing that value. So let's compile. This is a compilation. So first stage may we have the count 15, then we can have the count 20, then we have the count 25, but for all the increment value it is 6, 6, 6, it is 5, 5 and 5, sorry. So you can see here that whenever we call the function add increment, it increments the value of the count. But let's say if I write over here increment, that is, let's say 34, let's see what happened. So increment is a constant in a class definition, so it shouldn't be allowed to change that, right? So assignment of read only data member increment, right? So this is a read only data member, that is you just can read that value of this variable, so it is not possible to change the value, right? Also we cannot change the value of even count in the print class because this function is a constant function, so we cannot do like this. Now let's see the common errors while using constant object, constant member function, constant private data member, and a constant object passing to a function argument. So following are the compilation error. Defining as const a member function that modifies the data member of an object is a compilation error. Defining a member function that called a non-const member function of the class on the same instance of the class, and invoking a non-const member function with the const object. So with the const object you can only invoke the constant member function, you cannot invoke the non-constant member function because it will give you an error, right? For example, in the previous example here, the increment example, so let's see if we can the time example. So let's see, we can invoke set hour function, right? And let's comment out here the hours. So passing const time as this argument of void time. So because set hour is a non-constant function, right? Set hour is a non-constant function. In set hour it won't change the value of the private data member. I just commented out, right? Because set hour is a non-constant function, so that's why it is not possible to call that function using a constant object. Now let's see what is a friend function. A friend function of a class is defined outside the scope of the class. You have to tell through some mechanism that the function is a friend of a class, but the definition of that function is outside the class definition. It has the right to access the non-public and public member or the data member or the member function of the class. Prototype of friend function appears in the class definition, but the friend functions are not the member function. So here we have to use the keyword to make it different from the member function of the class inside the class definition. So हम friend keyword use करेंगे inside the class definition to make it different from the member function of that class, right? So they are called just like the normal function. Because for the member function we have to have an object of that class, then we can call a member function. But for the ordinary function there is no need for the object. You just need to know the mechanism, the number of parameters, the type of the parameter of that function, and the return value to call that function. So the friend function is called like a normal function. Friend function can be declared or can be placed anywhere in the class definition. Right, so place all friendship declaration first inside the class definitions body. So usually these friend functions are written at the beginning of the class definition to increase the readability of the class definition. Example is the count class. So friend function एक ऐसा function है, let me explain it. So friend function is एक ऐसा function है जो कि क्लास के पब्लिक और प्राइवेट डाटा मेंबर को एक्सेस कर सकता है, बट इट इज एक्चुअली नॉट द मेंबर फंक्शन ऑफ द क्लास. यू हैव टू टेल द प्रोटोटाइप ऑफ दैट फंक्शन इनसाइड द क्लास डेफिनेशन, एंड देन you can write the definition of that function outside the class definition, and you can call that function from any other function, and the calling sequence is same as calling the ordinary functions. In the count example, this is the count example. Now here we can see that we have a set x function, and that is the friend function of count class. And then we have some public function that is a constructor, default constructor, and then we have the function that prints the value of the x, and we have a private data member that is x. And outside the definition of the class, in the set x function, the first parameter is the reference and the second parameter is the integer value. So what we did is we just assigned that value in the private data member of C object, right? So here you can see we will see how we can call this function without set x function without the object name. Let's go to the class, to the program. In this program we use a friend keyword to make set x function as a friend of count class, right? Then we have a public main function and private function and a print function, that is these both are a public function, and private data member is just the variable x. Here we provide the definition of set x function. The first parameter to the function is the referenced object of count class, and then second value is the int value, that is a integer value. Now it is allowed because the set x is a friend function of count. If we just remove this statement, then this won't be allowed, right? So it depends upon the user of the OOP. Okay. Then in the main function we have a variable counter, then count dot x. After instantiation we return the value of counter by printing it on the screen, and then set x function ko we are passing counter, that is an object of count, and the value 8. Now this is a dereference object, means that it creates a name C for the memory location that is allocated for the counter object in main, right? So here set x be used as a friend function, so it can modify or change the value of counter. So here you can see the message display, and we're going to print the value of computer. The values are changed. Let's compile and execute this program. So counter x after initiation 0, counter x after call to the syntax friend function is 8, and press any key to continue. Using this pointer, the object's member function can manipulate the object's data. That is what we already know. How do member function know which object's data to manipulate? So member function, you call the member function using some object. Now you are not passing any information of object 1 to that function, right? So how or what is the mechanism to get access to the private data member of the class? And that is possible. So how do the member function know which object's data member to manipulate? And that is possible using this pointer. So whenever you call the member function of an object, and it implicitly, it means the C compiler implicitly pass this pointer, that is the pointer to that object, to that function. So whenever you write, let's say, inches or feet, and I told you about that within the add dest function we have the inches and feet, that is without the object name. Now these inches and feet of the object that call the add dest function, right? So there is no need to write the name of the object. So this is internally, actually it access that inches and feet using this pointer. So we have seen the use of this pointer, implicit use of the this pointer. Now we will see the explicit use of this pointer. So every object has access to its own address through the pointer called this. So every object you create, there is this pointer for that object, and this pointer points to the memory location where that object is allocated. If you create object C1, C2, C3, and if you call the function add, let's say get increment, get count, you can write C1 dot get count, then this pointer of the object C1 is passed to the function implicitly, automatically, or we can say it is passed by the compiler. So when you return the hours, it actually in the get count function, when you return the count, it actually return the count or access the count using this pointer internally, right? So this pointer is passed by the compiler as an implicit argument to each of the object's non-static member function. Now we'll see what is a static member function in the next topic. So this pointer is passed by the compiler, C++ compiler, as an implicit argument. That means it automatically passes this pointer to the called function, right? And that this pointer points to the object that actually called that function, right? The object that is on the left side of the dot operator. So an object's this pointer is not the part of the object itself, right? So this pointer is actually not the part of the object, but it points to that object. You have a pointer that points to that object. So the size of the memory occupied by this pointer is not reflected in the result of the size of the operation of the object. We will see what is the size of the function. Size of the function is a function. We have seen this function in the previous course, Introduction to Computer Programming. So size of function is a function that actually returns you the number of bytes occupied by that object, or by that type, or by that variable, or by that string, or by that structure, right? So size of function, then you pass something to the size of function, and it calculates the size of that thing, that argument. And calculating the size of that argument means it will tell that how many memory will be occupied by that argument parameter, right? I will show you this size of function when we open the dev C editor. So objects use this pointer implicitly or explicitly. So we have seen its usage of implicit. That means that if we have a function like get hours and it return hours, now that hour is the private data member of the object that called get hour function. Now how that function access hours of that object, or how it knows that this hours is the private data member of that object who called the function. It knows it because the compiler provide this pointer to the get hour function when that object called that function, and this pointer is the pointer to the object that called that function, right? So object uses this pointer implicitly or explicitly to reference their data members and member functions. Now what is the type of the this pointer? The type of the this pointer depends upon the type of the object. So non-constant member function of the class employee, the this pointer has type employee static const. So if the function is a non-constant member function of the employee class, the type of the this pointer will be employee static const. Now here the pointer is constant but not the object, right? And constant member function of the class, so the constant member function are called by the constant object, and constant object cannot call the non-constant member function, right? So this is what we have seen. So constant member function of a class employee, the type of this pointer has the data type const employee static const. Now here the first const in this case, so in this case this const keyword represent that this pointer is a constant. You cannot change the value of this pointer, right? In any case. Now this is the same in the second case, that this pointer is a constant, but this const keyword here, that const keyword represents that the object is constant object, because constant member function are called by the constant object, and constant object cannot call the non-constant member functions, right? So this means that the pointer so the constant object called the constant member function, the type of this pointer will be const employee const static const, right? I hope that is clear to you, that the second const here represents that the pointer is constant, that is in the both case, in non-constant member function or the constant member function, that you cannot change the value of that pointer. The pointer is the constant, right? Now in case of the non-constant member function, the object is not constant. In case of constant member function, the object is constant, right? In case you are calling a constant member function, the object should be constant, and in case of calling non-constant member function, the object is non-constant, right? So in case you call non-constant member function, the type of this pointer is employee static const, and in case of calling a constant member function, the type of this pointer is const employee static const. I hope that will be clear. Now implicit and explicit use of this pointer. So in this example, this is our test class, right? Okay, just ignore this thing, because I have taken this definition that is written outside the definition of the class. So we have a constructor, right, that initialize the value with 0, and if the value is provided, it initialize the value of the x with this value, right? So x is a private data member. Now in the print function, just ignore this thing as well. Now in the print function, you will see that we are going to display the value of x over here. So that is the implicit use of this pointer to access the member x. Implicit mean the compiler will use here this pointer to access the value of the private data member. But here in this case, in the second cout statement, we can use like this and this arrow operator x. So when we write this, we get the address of the object, and then we can use the arrow operator to access the value. This is same concept if we have a structure to a pointer, if we have a pointer to a structure, right? So if we have a structure and then we have a pointer that points to that structure. Now how we can access the member of that structure? We can access using the arrow operator, right? So this is the explicit use of this pointer. Explicit means that you have used it actually. Now the C++ compiler will not use it, right? But in the previous case here, if we just write x, then implicitly the C++ compiler will use this pointer, right? So this is the dereferencing with the pointer, and then when you dereference the pointer, you can use a dot operator to access that value of the x, right? Let's go to the example. So let's remove this thing. Now here we create a test object, assign it value 12, and then we print the value of that object. That's it. So when we call the print function, it will execute these three statements, right? Right, so that is the output. So this call is the implicit call of this pointer, implicit use of this pointer, and this is the explicit use, you have used it, and this is the dereferencing this pointer, right? So dereferencing means that you can read static as value at address this. So you reach at the memory location where the object is located, and then from that memory location you are accessing x. You can use dot and the name of the variable xyz. So here we just have x, so we can just have x over here, right? If we have y over here, int y, we can access either y or x from here, right? Let's say initialize y by 5. So if I write here dot y, so it will print y, it should print 5. I should write y over here as well. Now it should print 5, right? So you should know at this stage the difference between using this pointer with arrow and dereferencing this pointer with dot. So if we have a pointer, now we say we have a pointer, and with this pointer go to this pointer address by using the arrow operator and access this value. So this is same as we have a pointer to a structure, right? So whenever we have a pointer to a structure, we use arrow operator to access the member of that structure. Okay, to understand this concept in more detail, I will show you the example in the next lecture, that we create a structure. In the next lecture we create a structure definition, then we create a pointer to that structure, and then we will see that using that pointer to a structure we can access the member of that structure using arrow operator, and then we can dereference that pointer, and using dot operator we can access the member of that structure, right? So that is for the today's lecture. I hope you understand the concept and the friend function concept, and then this pointer concept. That is very important. In the next class we will see the static data member of the class, static object, and the friend class. Thank you very much.